Welcome back. This is the third tutorial on solving systems, and in this tutorial I'm going to show you how you can use your calculator and matrix operations to solve a system of equations. I'm going to use an example where we have three equations that involve three different variables, and the first thing you need to make sure is that each of these equations is in standard form, meaning that your variables are in order in all three equations and that all your numbers are on the right-hand side. You might also notice in this particular example that the second equation doesn't involve a z, and the third equation doesn't involve a y. So when I rewrite these equations, I'm going to use 0 as the coefficient to hold the place of those variables that are missing. So my first equation is good. I've already got all the variables in order, so I don't need to make any changes here. But in the second equation, I'm missing a z, so I'm going to put everything in order. So I still have the x plus 5y, but I also want to remember there is a z variable. It's just that the coefficient in this case is 0, and then the solution is 9. In the third equation, I need to be careful because my variables are not written in the same order. I need to make sure the x comes first. The coefficient then is negative 5x. Notice there's no y, so I'm going to have to put 0y. And then my z is going to be plus 4z, and that equals 4. So as I think about this system, I can also use matrix operations to solve it. And what I'll need to do is generate a coefficient matrix using all the values that are my coefficients for x, y, and z. So even though, for example, in the second equation there's no number in front of x, you have to remember that the coefficient is 1. And this is 5. And when the variable is missing, that means the coefficient is 0. And we've got negative 5, 0, and 4. So I'm going to create a matrix. I'm going to call it matrix A. Let me give myself a little bit of space here. And I'm just writing all the coefficients in the proper order. And you'll learn more about matrix operations in pre-calculus. Just kind of giving you a preview. If I take this coefficient matrix, I can multiply it by my variable matrix, x, y, and z, and that's going to be equivalent to my solution matrix. And I'm just going to call my solution matrix B. Negative 1, 9, and 4. And if I want to solve this system using matrices, I can use the matrix operation A inverse times B. And that will give me the solutions. So the trick is basically, it's not really a trick, but entering these values into a matrix on your calculator. You'll notice under the X inverse key, or below the math button, you'll see matrix written in blue. That means if I want to get there, I have to hit the second button first. And notice that the first menu just tells me the names of my matrix. And then I've got math. Those are going to be all my matrix operations. And then the last is the edit. I actually have to scoot over to the edit menu in order to enter the values of my matrix. I'm going to start with my matrix A. You have to identify the dimensions of your matrix, and that's the number of rows times the number of columns. Well, I have 1, 2, 3 rows and 1, 2, 3 columns. So I'm going to enter this in as 3 by 3, and notice that when I do that, it creates a matrix that has the dimensions that I need. Now I'm going to enter in all my coefficients, 2, 3, negative 2, and it'll enter them right in across 1, 5, 0. You can also use your arrows to move up and down. And then negative 5, 0, and 4. Okay. I don't need a variable matrix. I don't need to enter it in. And let me just be very clear that the X that I drew here is really supposed to be a time symbol. So let me make it actually look like a time symbol instead of an X. Because essentially what I'm going to do is I'm going to multiply the inverse of matrix A times B. Now to find the inverse of matrix A, it's a little bit more complicated than anything that we're going to do in this course. So I'm really not going to go through the steps. But what we do need to do is enter in our solutions into matrix B. So to do that again, I have to hit second matrix. I have to scroll over to the edit option, and now I have to select matrix B. I also have to identify the dimensions. Well, there are 3 rows and only 1 column. And notice again that my numbers go down just like they're supposed to. Now I can enter in the values of my solution matrix. Once I'm done, I'm going to hit second quit, so I'm back at my home screen. Now you may wonder what A inverse looks like. Well, let me show you. If I hit second matrix again, this time instead of going to edit, I'm just going to select matrix A. The inverse key is right below it, which is x to the negative 1. That actually just means I'm taking the inverse of matrix A. And if you think about it, anytime we solve an equation, we're using inverse operations. For matrices, it's a little bit more complicated. If you press enter, though, it'll actually give you your inverse matrix. And it's going to look crazy. But if you are going to solve the system using matrices, you do need to show your work. And so you will need to show this matrix as part of your work. And so you can just round everything to 3 decimal places. So my A inverse matrix is actually negative 0.909. I'm just going to go down since that's what I can see. 0.181, actually that's going to be 0.182 because the 1 is going to round up. And then the third one down is going to be negative 1.136. I can arrow over and that'll give me my middle column, which is 0.545. 0.0, I think that's 0.0. Is it 0.0? Yeah, 0.09. And I'm going to round the 0 up to 1 since the next number is a 9. Whoops, I think I went too far. Yeah, I did. So 0.4091, that's good. And then the third one down is 0.68, and that's going to round up to 2. And if I scoot all the way over, you know what, I think I copied the wrong. Yeah, I copied the wrong one. So let me just go back and check. Okay, so my first column is correct. Negative 0.909, 0.182, and negative 1.36. All right, so there's my middle. That's still... This is really hard to see. You know what we can do so that we can tell where we are in the matrix? If you go to mode, where it asks for, where it says float, if you change it to 2, let's just do 2. That'll change our decimal places. If I quit, I'm just going to hit enter again, and it'll give me that matrix, but now it'll give me everything so that I can see. Sorry about that. Let me just rewrite this thing. Okay, so when I now write my A inverse matrix, it's going to be negative 0.91, 0.55, negative 0.45, 0.18, 0.09, 0.09, negative 1.14, 0.68, and negative 0.32. All right, that's my A inverse matrix. I'm still multiplying it times my B matrix, which hasn't changed. So if I take matrix A inverse, so again, we'll do matrix. We'll go to our matrix menu, select A. I want to raise it to the negative 1, which is really just telling me to take A inverse. And I want to multiply that times matrix B. So again, I have to go to second matrix, but now I want to scoot down to matrix B. And so that's the operation that I want in my calculator. When I press enter, it'll give me my solutions. Now notice I fixed the decimal places to 2. So that's why it's showing as 4.00, 1.00, and 6.00. The solution, though, is simply 4, 1, and 6. And those values correspond to the values of x, y, and z. So x is 4, y is 1, and z is 6. Another way of writing that would be as an ordered triple, 4, 1, and 6. And you can see that it's so much easier using technology to find the solution to this system than it would be to try to do it by hand. But it is important if you are going to use the matrix operations on the test, if you're asked to show work, especially not necessarily on the multiple choice problems, but if you're asked to show work in the problems that give you credit for showing work, it's important that you actually show this A inverse matrix. So this would be my A inverse matrix times, this is my B matrix, and this is going to give me my solution matrix. So you do need to show that step in order to receive credit for showing your work. Let's actually go back and try one of the other problems that we tried earlier. I'm just going to copy and paste. We can actually do it with a 2 by 2 or two equations as well. So in this case, let me give myself a little bit more space. In this problem, we had x minus 4y equals 4, and we had 5x minus 8y equals 20. If I want to solve this system using matrices, now I'm looking at doing a 2 by 2 matrix. My A matrix is going to look like 1, negative 4, 5, and negative 8. My variable matrix, x, is just going to be x and y. And my B matrix, my solution matrix, is just going to be 5, oops, I'm sorry, it's going to be 4 and 20. So if I wanted to put this in my calculator, again, we'll do second matrix. I have to scoot over to edit and choose matrix A to enter in matrix A. But this is now a 2 by 2 matrix, and I can enter in 1 and negative 4. Notice I never changed my my decimal places, so it's showing everything as having exactly 2 decimal places. And we can just leave it like that for now. I also need to input my B matrix. So if I go to second matrix, again, go to edit first, scroll down to matrix B. Matrix B is now a 2 by 1 matrix, and I can enter in my values 4 and 20. I'm going to solve this matrix the same way, but I have to quit to go to my home screen first. Let me clear that out. If I want to find my A inverse matrix, I'm going to go to second matrix, choose matrix A, and then use my inverse button. When I press enter, it'll give me my A inverse. So A inverse times B is going to give me x. So A inverse is now negative 0.67, 0.33, negative 0.42, and 0.08. We already know my B matrix is 4 and 20, and my X matrix is X and Y. And if I'm trying to figure out the solution, then I'm actually going to type in matrix A inverse times matrix, and I'm going to scoot down to matrix B. And when I press enter, that will give me my solution matrix. So I know that 4, 0 corresponds to X and Y. And that's what I got before. So you can use matrix multiplication to solve any system as long as the number of equations you have is equivalent to the number of variables. That means that your A matrix, your coefficient matrix, will always be a square matrix. It'll always have the same number of rows as columns. I hope that was helpful. But do remember that in order to receive credit for the BCRs and the ECR type problems, you do need to show that A inverse matrix.